Hello everyone, and welcome back to another edition of Try Science. Last episode was so exciting. We learned all about ornithology. Do you remember what ornithology means? If you said the study of birds, you are correct. Hey, just because it's a new show doesn't mean you should forget everything you learned last month, right? Well, today we have another fun-filled and fruitful show planned for you. What is it, you ask? Well, here's a hint. What do you eat when you're hungry? Food, exactly right. But that was an easy question. But what exactly does food have to do with science, you say? Well, stay tuned to find out as we start this episode of Try Science, the Food Science Edition. Oh, hi, boys and girls. Excuse me, I was just enjoying a cup of coffee and thinking about food science. Coffee and science? What? That sounds crazy, right? But when you mix the dry coffee grounds with water, you create a soluble solution. That's science. Chemistry is the study of matter and how matter behaves and interacts with other kinds of matter. One important property of matter is solubility. We think about solubility when we dissolve something in water. If a chemical is soluble in water, then when you add it to water, it will dissolve or seem to disappear, creating a solution. If it is not soluble, then it will not dissolve and you will still see it floating around in the water. In today's first experiment, we will look at different types of materials from oatmeal to coffee to see which one is a soluble solution. Enjoy.
What is in each bowl? So what is this stuff? Yeah, oatmeal. What do you guys think that is?
What's that about? Rice?
Yeah, rice. So we have rice and oatmeal. This is something sometimes you put on your food. It's on popcorn.
Why popcorn?
This is salt. So we have cereal, we have rice, we have salt. Smell this. Sometimes moms and dads drink this in the morning. This is coffee. And the last one, give that a squeeze. See if you can smash up that big clump. You want to try to smash that one up? Do you guys know what that stuff is? What color is it? Let's start there. Is it purple?
No.
No, what color is that?
Brown.
Yeah, this is brown sugar. All right, so now you've figured out what everything is, so this is what we get to do with it. Let's start with the oatmeal. Can you take 1 scoop and put it in a cup?
Okay.
Yeah, okay, and then pass it on so Rocky can do it. 1 scoop in the cup, scooping. All right, so now you're gonna add 2 big scoops of water. So I'll do the first one. Can you add the second one? Yeah, there you go. And then you're gonna stir up the water and the cereal and see what happens. Great, okay, and use your stick and stir it up. All right, and I want you to look at your cereal. What's happening? What do you see? Let's remember that this cereal does what we call absorb, like a sponge. It soaks up the water. All right, so now I need you to dump your cup in this big container over here. Yep.
There you go.
Perfect. Good job, guys. Oh, there's still some rice sticking in there, isn't there?
Wow, so many different items dissolve in water, but there are still a whole bunch that don't. I guess that's why my cereal gets soggy after a while. Who knew? You know, apples are great for snacks or to have as a side dish for dinner, but keeping them looking white and delicious after they've been sliced can be tricky. In this experiment, we see how chemistry can keep your apples fresh even after they've been sliced. Let's have a look.
So each of you needs half a lemon. I'm going to put my lemon on top of the juicer, and I'm going to push and turn. And look at the juice that starts to come out. That's what I want. I want lemon juice. So this one's for you. There you go. So like twist. All right, let's see if you guys got any lemon juice. Let's pour. There you go. Oh, well done. All right, let's see about yours. Good. Okay, and then we're all done with those lemons. Can you put your empty lemon peels in there? So look at the liquids on the table. Can anybody guess what the L might stand for? Yeah, lemon. So we've got our lemon juice that you guys helped to squeeze. We're going to dip one slice of apple in the lemon and see what happens to it after it sits out for a while. Now, I'm going to pass this around. I want you to touch it, smell it, and see if you can figure out what it is. So touch, smell, and pass it on. This is letter B. This is something we use in the kitchen for cooking. Yeah, you got it. So our grown-up was helping us out. This is baking soda. So we've got our lemon juice for a piece of apple, our baking soda and water for a piece of apple. This one we're going to smell a little bit differently. So we're going to take our hand and sort of push the smell toward our nose, okay? See if you can recognize what that is. So put your nose close, but not all the way, and you're going to put your head down here. And you're just going to take your hand and waft the smell to you. Yeah, so some things that scientists might need to smell have very, very strong scents, and they could hurt your inside of your nose. So that's why we practice the wafting motion. Now this vinegar, that's our V, that won't hurt you, but we want to practice good science behavior. All right, so we've got our L, we've got our V, we've got our B for baking soda, we have W and P. What starts with W and is a clear liquid and comes out of the water faucet? Water. So we're going to dip one of our apple slices in water. What could the P stand for? Anybody have a guess? When you do science, you always need to have, if you're doing an experiment, you need one thing that hasn't had anything dipped, you haven't dipped into anything. So P is our plain apple slice. All right, so we're gonna start dipping. So put all your apples in the middle of your plate. Put them all in the middle. Here comes the V. I want you to dip one apple, drop it in, take it out, and put it next to letter V. And we want to set it so that our peel is on the bottom. Okay? Drop one in. And I'm going to start you now with W. So drop it in. Okay, put it next to the V. All right, here's the L. L for lemon. Now, you have two left. One needs to go next to P. That's one with nothing on top of it. So what we're trying to figure out, guys, is which apple turns brown the fastest, and which one does not turn brown. So we've dipped them in different substances. What is going to happen to our apples?
Those kids did an excellent job with that experiment. I followed along as well, and here's what I came up with. My apple in the baking soda was a bit of a disappointment, as well as the water. But the vinegar and the lemon juice worked like a charm. You want to know why? When an apple is cut open, an enzyme called polyphenol oxidase is released from the cells of the apple and reacts with the oxygen in the air. This reaction causes the fruit to turn brown, similar to rust forming on metal. Lemon juice helps keep the apple from browning because it is full of something called ascorbic acid, or vitamin C. Besides lemon juice, lime juice and cranberry juice also work well. You may want to try several of these juices and find a tasty way to serve sliced apples in the process. Now on to our next experiment for our food science edition of Try Science. Have you ever wondered why marshmallows don't sink in your hot chocolate? Well, take a look at this.
Now you're going to put that marshmallow in the water. Does it float up at the top or sink to the bottom? Yeah, how about yours, Rocky?
You might be wondering why your marshmallow floats. This is due to tiny air bubbles. These little air bubbles make the marshmallow less dense, causing it to float. Think of it like a submarine. If it has a lot of air, it floats. If it has no air, it sinks to the bottom of the ocean.
We want to get it into a tiny little ball. Yeah, now are your fingers getting sticky? Mine are. So I'm going to roll it in this stuff called cornstarch. You have some next to you, Bobby. So you can put your marshmallow in it and kind of pat it. And you want your marshmallow to get nice and dry with the cornstarch. And then you can squish it some more. Squish, 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 squish. Okay, let's test. 1, you're going to drop it in when I count to 3. 1, 2, 3. It did. Oh, yours is stuck to your fingers. Let's see if we can plop it off. Oh, let's see. That one was still floating, but we've got 1 on the bottom, 2 on the bottom. Let's see if we can get this one to go to the bottom. Look, guys. Rocky's marshmallow. See it on the bottom? Yeah.
Well, I don't know about you, but I like to keep my marshmallows fluffy so they float. But that is my preference. I am a floater, and I am proud to say that. And speaking of floating, have you ever grabbed for a soda in a cooler and noticed that some sink to the bottom while others float on the surface? Well, why is that? And why do I always get my sleeve wet trying to grab one? Well, I think we can answer at least one of those questions with this next experiment.
We're going to see if this soda sinks to the bottom or floats on the top. Can you choose one soda? Yep. All right, put it in the water and see what happens. So let's wait. Float or sink? Sink. Okay, can you reach in and take it out? There we go. All right. So that one sank. So let's put it over here. Sink. All right, test this one out. Okay, now wait. Float or sink?
Float.
Float. All right, can you reach in and get this one out? There we go. Oh. Good. All right, you can put it right over here. Let's take these over to the scale. So can you roll them on the towel? We're gonna dry them off. All right, so we're gonna turn that on and wait for it to say 0. There we go. All right, let's try the blue Pepsi. Let's put it on the scale. Yep. Put it on top and put your hand off. All right, let's see. This says 13.3. So remember number 13. You do that one. Okay. Okay. 12.6. Oh, this one is lighter. Let's try that one. 12.4. Ooh, light, medium, heavy. These ones floated, and that one sank.
Do you know how much sugar is in that can of soda you drink every afternoon? It's well known that sugar accounts for the high calories in soda, and it's not a healthy substitute to plain H2O. But just how much is in that can, and what about diet soda? Start by placing different types and brands of soda into a bucket of water. Why do some float and why do some sink? We are going to use regular and diet soda in our example. Both cans are the same size and hold the same volume, 355 milliliters. The regular soda weighs about 384 grams, while the diet soda weighs 371 grams. The regular soda has 140 calories. The diet soda has 0 calories. Are the calories the thing that makes it weigh more? Sort of. You see, the regular soda has 39 grams of sugar, But what does that mean? About 18 packets of sugar in 1 can of regular soda. The reason the regular soft drink sinks is the sugar content. If you drank 1 can of soda every day for a year, you would consume 32 pounds of sugar. Yikes! 32 pounds of sugar in a year? I think I'm going to just stick with good old-fashioned H2O. It's refreshing, cheaper than soda, and good for you as well. And speaking of water, have you ever tried tonic water? It's not very good. It's kind of sweet and bitter at the same time. However, you can use tonic water for your very own food science experiment. How, you ask? Well, all you need is a black light. Whoa, where'd I go? Well, the reason that tonic water glows is because of an ingredient called quinine. Quinine comes from the bark of the cinchona tree. There are also several other foods that light up under a black light, including something fun and gooey that you can make at home called oobleck. Let's take a look.
What do you guys think is in that bottle? What does it look like? It does look like water. Good, it's a special kind of water called tonic water. Put that water in the box. What color did it turn? Blue. So that's that's right. That's a special light called a black light. And when we put this special water underneath, it turns blue. This water has something called quinine in it that makes it turn blue. Look at what I've got here.
Milk.
That looks like milk. Touch it. Does that feel like milk? It is gooey. So we've mixed cornstarch. Yeah, look at that. Cornstarch and tonic water. So let's see if we can get this to glow under the water. You guys think we can? All right, guys. Can you scoot back? I'm going to put this whole container in. I'm going to bend down so we can both see it. So there's our tonic water. We'll bring it up close.
That is good.
Is it glowing?
Yeah.
Look, let's pick it up. Whoa, can you guys make it drip like that? I'll get out of the way. Whoa! Now it's okay if it drips on the box or if it drips on your hands, that's all right. Gooey. Do you guys want to make some of that? Yeah. All right. Come on over to our table. So the first thing you need is some cornstarch. You can get on your knees if that's easier.
Yeah.
All right, and we need a scooper. Can you put 2 scoops of cornstarch? Here's your spot. Oh, that's great. Big one, yeah. All right, ready? And you can do 2 scoops. Oh, big one.
It's a mountain one.
It is a mountain one. All right, let's put this in. Now we need to put some scoops of water in there, and then you're gonna stir. Ooh, good save. You don't know what it's doing. All right, so we want to get all of our right. Yeah, mix with your fingers. Can you put your fingers in and mix? You can. Oh, look at that. It feels like hard, but when you squeeze it, it drips. Oh, you've got perfect consistency.
I'm a gooey monster.
You are.
Gooey monster.
Woo! Okay, keep them. Yeah. Oh, well, here we go. Here we go. Ready? High five. Yeah. High five, monster. High five. Yeah. All right. So, guys, here's what I want you to do. I want you to hold your hand and let it drip into the cup, okay? So you don't have any more dripping.
Well, there you have it, boys and girls. Another fun-filled, scientific, terrific time right here on Try Science. A big thanks and shout out go out to Miss Megan at the Delaware Children's Museum for all of her help and scientific information. Remember, if you would like to be a part of all of this excitement, you can come on down to the Delaware Children's Museum the second weekend of every month from 11 to 12 p.m. or from 1 to 2 p.m. And maybe we'll see you on the next episode of Try Science. Well, I'll leave you with a quote from Anthony Burgess, who said, "I didn't think, I experimented." Have a great day.